Hi everyone, today we are presenting our system design project Vascom, a social commerce platform that combines product shopping with short form video content. Before we begin, let me introduce my teammates. I'm Satyapriya and here are my teammates Shitu, Yashwant and Neil Murishwaran. Together we worked on designing and developing Vasco. The main idea behind Vasco is making product discovery more enhancing. In traditional e-commerce, users usually find products through search, category, or statistic product listing. But today, especially among Gen Z users, many products are discovered through short form videos and user content. The problem is that discovering a product through social content and actually shopping for that are often two separate experiences. Vascom aims to bridge this gap by bringing short form videos through Reels and e-commerce together in one single platform. User can discover products through Reels, interact with the content and directly access the associated products. Another important aspect of Vasco is curiosity and accountability. Vasco creates curiosity by allowing users to discover products through enhancing short form Reels instead of searching for them. At the same time, accountability comes from direct connecting the creator, reel, and the products. User can all easily move from content to actual product without searching separately. So Vascom makes product discovery both enhancing and reliable.
Moving to the second slide, this explains the purpose, process and people of Vasco. The main purpose is to make product discovery more engaging by combining social content and shopping. The process begins when a creator publishes a reel. The media and its metadata are then stored and the reel is linked to a specific product. After that, the customer can discover and engage with the reel and finally open the associated product. So the overall process is publish reel, store media and metadata, link reel to product, discover and engage and open product. The main people involved in this system are Gen Z customers, influencers, creators, sellers and online shoppers. This process connects content creation and product discovery into a single shopping experience. Finally, this slide represents our 3C system design competency. The first area is the user and product thinking, where we focus on user experience, problem identification and product discovery to solve the disconnected product discovery and shopping experience. The second is logical and system thinking, where we focus on problem solving, data flow and architecture. This helps us manage the complex interaction between the front-end, API, database, storage and users. The third is the technical implementation, which includes authentication, API, database, storage and performance. These components help us achieve efficient and reliable handling of the reel and product data. Overall, these three areas show how Vasco combines user needs, system architecture, and technical implementation to create an effective social e-commerce platform. At the front-end layer, we have a React-based user interface through which customers, influencers, sellers, and delivery users interact with the application. Before accessing the application, users go through authentication and authorization. Authentication determines who the user is, while authorization determines what the user is allowed to access. We have implemented role-based access control where different roles such as customer, influencer, seller and delivery have different application workflows and protected routes. After authentication, the front end communicates with the required services through defined interfaces. For the Reels feature, the front end sends a request to our Vasco Reels API. Now let us discuss about the technology stack of Vasco. The workflow follows Vasco Reels API, then fetches the details and returns the Reels JSON. The application uses Supabase for persistent data management. We have two main database tables, products and the Reels. For media, we use Supabase storage. Reel videos are stored in the Reels bucket, while product images and Reel thumbnails are stored in the images bucket. This also demonstrates separation of concerns because structured application data and large media files are handled separately. The front end receives the required reel information as JSON and uses it to render the feed. Now let's see these concepts work from the user's perspective.
We will now demonstrate the customer workflow starting with authentication. This is Vasco login interface. Authentication is the first layer of our application because the system needs to know which user is accessing the platform. After successful login, the user is taken into application according to authorized role. Vasco also implements role-based authorization. Different users have different responsibilities within the system. For example, a customer can access shopping and reels, while an influencer can access creator-related functionality. Protected roles check whether the user is authenticated and whether the user's role is permitted to access the particular section. This prevents different application workflows from being mixed together and provides a clear boundary between user roles. Now let's open the Reels section. This is our Reels field, where customers can discover products through short form videos. When the Reels page records data, the frontend does not simply load the entire collection at once. Instead, the system uses pagination with limit and offset values.
Now let's look at what happens behind the Reels feed. When the customer opens the Reels section, the front-end requests Reel information through our Reels API. The backend workflow follows three main stages: Vasco Reels API, fetch details, and return Reels JSON. The front-end then receives this JSON response and converts the information into the Reel objects used by the application. This demonstrates the API-based communication and separation of concerns. The UI does not need to know how the backend retrieves the information. It simply requests the required data through the API interface. The structured information is maintained in the Supabase database. We have two main tables: product, which contains the product related information, and reels, which contains the reels related information. A reel can be associated with a particular product using the product relationship. This allows a customer to watch reels and then open the product associated with that content. This is an example of relational data modeling, where we avoid duplicating complete product information inside every reel. For media files, we use the Supabase storage. We have a Reels bucket for reel videos and image bucket for product images and reel thumbnails. We don't store the actual large video files directly into our database. Instead, the database maintains the relevant information and URLs, while the actual media files are maintained in the object storage. The separation is useful for media-heavy application because the database records and large media files have different storage requirements. Each reel can also be connected to its associated product. When the customer selects the product from the reel, Vascov navigates to the corresponding product details. This is what connects our social content directly with the shopping experience.
We also prevent multiple Reels requests from being triggered simultaneously during the rapid scrolling. This helps avoid unnecessary duplicate API requests. Another performance optimization is related to the video playback. We use visibility-based control for reel videos. When a reel becomes sufficiently visible on the screen, its videos can play, while videos that move out of view are paused. This avoids having many videos playing simultaneously and reduces the unnecessary resource usage. We have also considered the fault tolerance. If a primary reel API does not return usable data, the application may attempt to retrieve reel information through Supabase as a fallback. If the media itself failed to load, the application can fall back to the available thumbnail. Therefore, the system does not depend on a single successful operation for every part of the user's experience.
So far, we have demonstrated the customer side. Vasco also provides workflow for creators or influencers. After authentication, the creator can access the creator section and publish product-related video content. The workflow is: create product video, then upload video, then store the video, create reel metadata, and link reel to product, and then publish. The video is stored in the Reels storage bucket, while the reel information is stored in the Reels table. The creator can also associate with the reel with the product using product identifier. This association is what allows customer to move from influencer content directly to the corresponding product. This creates the core social commerce loop of Vasco.
Now, let's connect our implementation back to the system design concepts. Vasco uses authentication and role-based authorizations to control access to different user workflows. We use separation of concerns and modular architecture by separating components, pages, hooks, services, types, and utilities. We use API-based client-server communication for the Reels workflow. We use persistent database storage through Supabase for products and Reels. We use object storage for large media and such as Reels videos, product images, and thumbnails. We also implemented fault-tolerant fallback mechanisms and media fallbacks to improve reliability. Finally, we use visibility-based video playbacks as a performance optimization for Reels experience.
To conclude, Vascom is not a single e-commerce application with videos. Our goal was to combine social content discovery with product shopping and build the supporting architecture around the experience. Starting from authentication, we implemented role-based access to support different users' workflow. We separated the front-end API key, services, database, and storage responsibility so that each part has a clear purpose. Our Reel feature uses API-based communication, infinity scrolling, request control, and feedback to provide a more reliable and efficient experience. Superbase provides database and object supports, allowing us to separate structures information from large media file. Most importantly, we applied these system design concept directly to visual product workflow rather than treating them as a theoretical concept. The complete workflow is content creates product content, then Reels is stored and linked to the product, then customer discovers the Reel, then customer enhance with the content, then customers open the associated product. This is the Vascom, a social commerce experience designed around the way modern users discover products. Thank you for watching our demonstration.